Now that we have a model, we have our equation that we got from analyzing this data here. What we can do is we can now use this model to plug numbers in and to predict things. So what I'm going to do is off to the side here, I'm going to write M1, and then underneath it, I'm going to write B1. I'm going to make a couple spaces, or at least one space. I'm going to write M2, and then I'm going to write B2. And what this is going to correlate to is it's going to be M1 is the slope for data 1, for my equation 1, and B1 is the y-intercept of this equation as well. And there are other ways to do this, to do it a little bit more cleanly, especially if you're going to be doing something a little bit more important, or where the actual numbers are super, super important. We're just going to type this number out. I'm going to do it just by inspection here. I'm going to look at my equation here and say that my slope is 10.1. And so I'm just going to write that, 10.1. And my b, that's what we add to it, is going to be 0.558. I'm going to do the same thing for my second equation. My slope is 9.08, and my b is 3.35. And this is going to work the exact same way in Google Sheets as Excel. So I'm only going to do it here, even if you're using Excel. What I'm going to do is I'm going to put over here, I'm just going to write an equal sign. And again, you can make this a little bit neater if you're going to do this on your own. Take some time to make it neat. I'm going to make an equal sign. And remember what that equal sign means is it means that we're going to have it do some calculations for us. And what I'm going to do is I'm going to say, take my slope, which is going to be 10.1, so I'm going to click on it, and I want to multiply that by some input. Now I didn't have a spot for an input. I'm just going to click here on L2 for now, and L2 is blank right now, so essentially there's a 0 there. So this is my slope times 0, or in other words, my slope times my variable that is in L2. That's going to be my x. And then I want to add my y-intercepts to it. So I'm going to click over here on 0.558. Now remember, I said up here in L2, it's using whatever's in here as a variable. There's nothing there, so that would be like putting a 0 in here. And if I put a 0 into this equation, well, 10.1 times 0 is 0, so my answer should be 0.558. But now what I can do is I can change this, and it's going to update. I'm going to put a 1 into this. If I put a 1 into here, I get 10.658. Now that is relatively close to what our y was for y1 when I put a 1 in. That was 10.0. It's not exact because remember, we made an equation, we made a model. So it's not perfect, it's just going to tell us approximately what it should be based off of our data. Again, if I put a 2 into here, then I get something very close to 20.9. And if I put a 3 into here, I get something that's close to 31.6. Now again, it's not going to be perfect, but what this is it took this data, it made a model, and now we're going to use that model to make predictions. And it doesn't do much good to make predictions off of numbers we already know. Plugging in numbers 1, 2, and 3 into there are nothing more than making sure that it seems to be working. We're getting numbers close. But what I can do is I can put something like 3.25 in. And it should tell me what's happening between these data points. So this is right around here on my line. And so we'll see that we're just a little bit above what we were at 3, and at 3 we're at 31.6, and we are just a little bit above that. And what if we wanted to extend past 10 and say, if this model continued on forever, what if I were to put the number 15 into here? Well, then we would be up to around 152, which makes sense. We'd be somewhere up over here and this goes 100, 125, 150 would be somewhere up here. And so it can kind of forecast or can tell us what an answer should be, even if it doesn't fit onto here. We have to be able to be confident enough in our model, in our equation, that we can do this. So we need to know a little bit about where the data came from. We have to know kind of the range that the model works for, and we have to know how accurate our model is as well. And that's again what the R squared value gives us.